Hello. So today we're going to go through a review of equation solving. This is something that you have done before, and think of it as when you're trying to solve a puzzle, what you're doing is looking for everything that is missing. So we're doing it now just from a math perspective. So let's say I gave you something like this. All right, so here's something missing, and we're wondering what number, when you add 3 to it, you could get 5. So this is like a puzzle. Wouldn't take too much thinking in a case like this to come up with the magic answer here being a 2. So if we said 2 is the answer, another way of saying that is that 2 is the solution to this equation. So why is this an equation? Well, equations right there have equal signs. And what an equal sign does, it splits the equation into two sides. We have a left side and we will always have a right side. So instead of using boxes and empty things here, we end up using variables or letters. So the letter, this could have been, if I were doing this in a high school math book, this would have been an X. And I would be saying, same idea, what number plus 3 would equal 5? So we are going to solve this equation. So the idea is what we want to do. Here's your plan. You're trying to get all of the variables you see to one side. So right now there aren't any very many variables except this X. So we don't have to worry about it. This X could have been on the left, it could have been on the right, I could have had X's all over the place. So as we go through the examples today, they'll get tougher, but your ultimate goal is to get the X or M or whatever it is all by itself on one side. Make sure it has a +1, a positive 1 in front of it, and nothing else on that same side. So an X all by itself on the left, or an M or whatever, or a letter all by itself on the right-hand side, and then on the other side will be a number. And that number is actually your solution, okay? So where should we always start? Since we're focused on looking at the variable, you should always look in the question that you're given if the variable's on the left or the right, and then that's the side that you start on. So in this case, I would definitely start and do my work on the left-hand side, okay? Now, how do we truly solve something? I said I want to get this X by itself, so somehow magically this 3 needs to disappear. Well, we can't simply make things disappear because they are there. So it's a mathematical procedure where what we're really doing to try and remove this 3 away from the X, we're going to do a balanced little operation. So we have to recognize what's going on, and we have to be able to find the opposite operation of what's going on. So on this X all by itself, I have to get rid of a +3, right? How do you get rid of a +3? It would take minusing 3. But in math, the idea of balancing, whatever I do to the left, I have to do to the right. So if I minused 3 there, I also have to minus 3 there. So what's going to happen on the side that you started with, they will cancel out and have just a irrelevant value. +3 minus 3 is 0. So I really don't need to say X plus 0. I can just say all that I have left there now is an X, and then I'll work this side out, and there you go. That's the solution, okay? So you would call 2 the solution. It's a really good idea anytime you're equation solving to check your work. That means you write down what you were given, you take your answer, and you put it in for the letter, for the variable. So I'm going to put a 2 in there because I think the solution is 2. And then the check is, what does the left-hand side equal? What does the right-hand side equal? And as long as they're the same, then you really did find the correct solution. So 2 plus 3 is 5. This side is 5. So would you argue with that statement? 5 equals 5? Hope not. That's a true statement. So therefore, that's letting you know your solution is correct. So I did an opposite operation of what I saw there, okay? So here, let's do another example or several more. How about -3 equals m minus 10? This is an equation. It has a left side and a right side. I see the m. I need to get it by itself. So the -10 or the -10 has to go. How do you undo or get rid of a minus 10? You add 10. But if I did it there, I have to do it here as well. So once we figure this part out, that just totals 0. So I'm not going to say m plus 0. I would just say there's an m left, and then negative 3 plus 10 is a 7. If I want to check my work, I write down what I was originally given. I think m is supposed to be a 7, so I'm going to put a 7 in here. And I'm going to see if I get a true statement or a false statement. This side is negative 3. 7 minus 10 is negative 3. That's a correct statement. Negative 3 does equal negative 3, so I'm done. Okay, another one. Negative 7.2 equals negative 3.2 plus x. It is an equation. I have a left side and a right side. I'm trying to get the x by itself. So be careful. This is a minus 3.2 or a negative 3.2. And this is a nice positive 1x right here. To undo a negative 3.2, I would put a positive 3.2. I'm subtracting 3.2, so the opposite is adding. Do it here as well. This cancels out to a 0, so all that's left on the right-hand side is an x. And if I went through here, and I can use my calculator, I would get an answer of negative 4. So I'm done. All right. And what makes things usually tougher is throwing in some fractions. So how about if I had a plus 1.5 is negative 1 and 5/6. All right, so I have an equation. Here's my a. I need to get rid of a plus 1.5. So I would minus 1.5 and minus 1.5. These are gone. So I now have a problem. I've got negative 1 and 5/6 minus 1.5. These are called mixed numbers. I really want to change these into improper fractions. So the way we do that, you take the full number, times it by the denominator, and add on the top. So a 1 times a 6 is 6, plus a 5 is 11. So I really have 11 over 6, and that's negative. Then there was a minus sign. I'll do the same thing here. I'll times these two together and then add on the top. So 1 times 2 is 2, plus 1 is 3. So now it's looking better, but I can't add these together. These are a size called a 1/6. These are a size called a 1/2. You don't go by a size 6 shoe and a size 2 shoe. You need them to be the same. So we have to find their lowest common denominator. For a 6 and a 2, that would be 6. So this one needs a 6 on the bottom, and this one needs a 6 on the bottom. This is already a 6, so nothing here has to change, but to make a 2 into a 6, I had to times by 3. So I'll have to do that to this top to have the proper new top here. So 2 went times 3, so now 3 goes times 3, and my new numerator is negative 9. Now everything is the same size pieces. We can put them together. The way you would do this is, I would think of this as changing this to adding a negative. So what you do with fractions, you add the tops, you keep the denominators alone. So I know my answer is going to be some kind of 6ths. So negative 11 plus negative 9 is negative 20. And we know with fractions we're never done until we look and see if we can reduce. They have a greatest common factor of 2. So if I reduce these, I will get a new final lowest form solution of negative 10 over 3. So that is the magic number that I was missing to solve this. Okay, so what have we seen? If we have adding, we undo adding by subtracting. If we had subtracting, we do undo subtracting by adding. But there are other operations in math. We also have multiplying and dividing. So if I have to undo multiplying, I would divide. So if I see a variable is being multiplied by a number, I'm going to get rid of that number to isolate the variable by dividing. So example, so now we're looking at multiplying and dividing. Okay, so how do I undo that or get that variable isolated when that's the operation connected to it? So 5y is negative 20. Okay, it's an equation. My variable's on the left. I need this 5 to go. So you have to recognize what's holding the 5 onto the y. Multiplying. This y is being multiplied by 5. How do you undo multiplying by 5? You divide by 5. And remember, we have to do it to both sides. So divide by 5 here. This line is really the best way. Instead of showing a divide by sign, just that line making this a fraction indicates I'm dividing. So this side gets divided by 5 and this side gets divided by 5. Now this is 0, right? Over here when we did this, we got 0 because two values canceled each other out because they were equal but opposite signs. This is dividing. 5 divided by 5 is a 1. So that's what's left there. But we know we don't have to bother writing the 1, so really this 1 can disappear. So it's not a 0, it's a 1. And now I do negative 20 divided by 5, and I get an answer of negative 4. If I want to check to see if this is the correct answer, I take what I had in the beginning, but here I put in my solution. So this says 5 times negative 4, because that's what I think the solution is. That is supposed to be negative 20. So these two together are negative 20. The other side had a negative 20, and that all works nicely. So my check shows me that what I did is correct. Okay, and one more here. Let's say I had negative 16 equals W over negative 2. Okay, it's an equation. Now my variable is on the right-hand side. What is connected to it? A divided by negative 2. How do you undo or get rid of a divided by negative 2? You times by a negative 2, right? So this 2 is really up here. I'm timesing. I'm trying to create this 1. So putting a 2 up here, these will cancel. They both become 1s. But if I did it to this side, I have to do it to this side. So over here, I'm going to times by this negative 2 over 1 as well. So, sorry, it's hard to kind of see here. How do you times fractions? Well, that's the easiest thing to do with fractions. You times numerators together, you times denominators together. So negative 2 times negative 16 is positive 32. 1 times 1 is a 1, so I could write a 1 underneath here, but anything has a 1 underneath it, so I don't have to. Everything here canceled into these nice 1s, so I'm left with 32. That's the solution. That's the magic answer. So think about that. If there were 32 here, 32 divided by negative 2 is negative 16. So my solution or my answer must be correct. Okay, so let's have a look at 2 more, and then I'll tell you what you can do in your booklet on equation solving. Again, like I said before, fractions are kind of what makes us think things are tougher than they really are. So if you were given this, knowing what we just said about fractions, these two things are being connected right now through multiplication. So one way of looking at this is I'm going to multiply the numerators and multiply the denominators. There is a 1 here. So if you want, you could say 1 times x is x, and 4 times 1 is 4, and then the other side is negative 3. And now this looks exactly like the questions we were doing. This x has a divided by 4 connected to it. So to get rid of a divided by 4, I would go over here and times by 4. But if I did it here, I have to do it here. These 4's cancel because it really is saying 4 divided by 4. So that's a 1. So I have a 1x left here, but I'm just going to write x. And negative 3 times 4 would be negative 12. So that's one way of looking at this. But I'm going to show you another example where you could tackle this differently. And you have to get used to dealing with fractions because they exist and they're going to be around, and it doesn't mean always reach for your calculator. Let's say I have this one here. And just because of the fractions, it looks tougher than it really is. So I could start the same way I started this one. I could put a 1 underneath here and multiply this all together and get 3m over 10. But in this case, I don't think that's really a benefit or that's going to help me. I'm going to think in my mind, if I want this gone, I want this to be a 1. What would cancel out a 3? Well, a 3 down here would cancel out this 3. And what would I need up here to cancel out a 10? I need a 10. So that's called a reciprocal. If I went over here and times by the reciprocal of 3 over 10, everything here will cancel out into these 1s that I was aiming for. So that's a wonderful plan. But if I did timesing by 10 over 3 to this side, I'm going to have to go over here, use my brackets, and show very clearly that I'm also multiplying this side by 10 over 3. So these all cancel into 1s. So on this side, there's a 1m. So there's an m. Timesing is easy. 10 times negative 2 is negative 20. 3 times 5 is 15. But I have a fraction. I'm going to reduce the GCF. In other words, what can be divided into both of those would be a 5. So if I divide the top by 5, I'll get negative 4. The bottom by 5, I get 3. And there is now my solution. Okay? So we've covered a lot of stuff here. How we undo adding, subtracting, multiplying, and dividing. But what, I don't know if you've noticed so far, every example I've given you, the variable was always in a numerator. What if it isn't? Let's say I gave you this question. Okay, t. This is very, very different from everything that we've had so far. It is an equation, for sure. The variable is on the right-hand side, but this is bad news, having the variable in a denominator. I do not want it there. So what is happening right now? I have a divided by t. I don't want to be dividing by t. I want that t in the numerator. So how can I get rid of a divided by t times by t? Because they'll cancel. But if I did it on that side, I'm going to have to do it on this side as well. So what we did with numbers, we can do with letters. So these will cancel into 1s. So negative 12 times 1 is negative 12. Negative 2 times t is negative 2t. We write the numbers first and then the variables. Okay, I have t being times by negative 2, so I will divide both sides by negative 2. These reduce to a 1 or become a 1. So there's my t equals negative 12 divided by negative 2 would just be a 6. Okay, so that is a different example, but we've now covered everything when there is one thing to move away from your letter. So you should go to your booklet now and work through pages 38 and 39. 38 and 39. Okay, you'll have lots of practice. The answers are at the back of the book. And then after you do that, then you'll come back for the last section here. Okay, so we're at about 18 minutes on our video. So after you do these, then you can come back here and start the video at 18 minutes. And we're going to finish off with how could this get tougher? Well, the way this gets tougher is when there is more than one thing on the side with the variable. So you have a few choices now to make. So here's an example of, it's easier just to write this out so you can see what I'm talking about. It is an equation, my x's are on the right-hand side, but there's two things to get rid of. There's a times by 5 to get rid of, and there is a plus 7 to get rid of. So it absolutely matters which one you get rid of first. In other words, which one you move to the other side first. If you don't do it in the proper order, you will get the wrong solution. So here's how I want you to think of it. Think of this as you, okay? You're this letter. These are your friends or these are your acquaintances. You've got a very close acquaintance, somebody who's right next to you, and then you have another acquaintance that's kind of further away. So given a choice, if you had to give up or let go of one of these friends, would you get rid of the one closest to you first, or would you get rid of someone who's more of an acquaintance than a friend? You'd get rid of the one farther away. Okay, so this is a real opposite idea of BEDMAS happening here. It's literally look at the variable, what's farther away on the same side that it is on though, you get rid of that one first. And then everything just step by step, everything flows. So I'm going to get rid of a plus 7 by going minus 7. But then I had to do it here as well. So negative 3 minus 7 is negative 10. Then I have my equal sign. I haven't touched that 5x, and these two totaled 0. Okay, how do you get rid of a times by 5? You divide by 5, and then you do your work. Negative 10 divided by 5 would be negative 2. 5 divided by 5 is that 1 we're going for, and then you have an x. So this is your solution. A check would be very easy. Here's what we started with, but we're saying now here we're going to throw in a negative 2. And let's see if we get a true statement. This side is negative 3. 5 times negative 2 is negative 10, plus the 7. This side is negative 3, and that side is negative 3. You ended up with a true statement, so now you know your solution was correct. Okay? So we can take this, do another example. Let's throw in some fractions here. How about this? The more things we add to equation, the tougher it looks, but you're always going to follow the same rules. You're going to look where the variable is. So we're absolutely starting on this side. What would you get rid of first? This is a positive 6. This is a negative 2/3. What is closer to the letter? The negative 2/3 is closer. So you're going to get rid of the positive 6 first. How do you get rid of a positive 6? You minus 6. They're just trying to make this on this side look tougher than it is. 4 minus 10 actually is a negative 6. So if there's something you can work out, go ahead and work it out first. So to this side we did a minus 6. So to this side I have to do a minus 6. These will cancel each other out. Don't forget the negative here. So this side still has your negative 2/3 y. We have our equal sign. Negative 6 minus 6 is negative 12. And like I said before, you are going to get lots and lots of fractions. How do I get rid of a 2/3? What would be really nice to times a negative 2/3 by would be a negative 3/2. The reciprocal of this. So my 3's cancel, my 2's cancel, and 2 negatives make a positive. So that entire thing became a 1 in front of the y. I now have y equals. But if I did that to this side, I have to do a negative 3/2 to this side. This is just timesing fractions. I'll times the tops, times the bottoms, and reduce. Negative 12 times 3 is 36. 1 times 2 is 2. This says 36 divided by 2. So my solution is 18. And I could go ahead and check that. Okay, so one more example. It's kind of a tougher one, but that's where things are going. We're going to get tougher. What if you had, sometimes there are decisions to make, and we all make good decisions, and sometimes we make not so good decisions. Let's say I gave you this, and I said solve it, because these typically all would start with solve. What should I do first? Okay, that definitely is the variable. What is closest to it? Well, these brackets are changing things. You know, this stuff, we know because of bed mass, stuff inside a bracket definitely belongs to that variable. So I could say, you know what, this is closer to the x, and this 4 is further away. So maybe I'm going to get rid of that 4 first. So let's go with that. Let's try that plan first. So how do you get rid of a times by 4? You would divide by 4 and divide by 4. That's created a fraction for me, and that's not really what we like to try and do, is create fractions, but that's what I have by the choice that I made. So over here is 5/4. That divided by that is just a 1. So having a 1 here and multiplying a 1 through to everything would just leave me that. Okay, to remove a minus a half, I'll go plus a half to this side, plus a half to this side. So this side says 5/4 plus a half is x, because these became 0. Now I need a lowest common denominator. I can't add different size fractions. So their LCD would be a 4. So this one doesn't have to change. But if I want this 2 to become a 4, I had to times by 2. So doing the same operation to the top makes this not a 1 anymore, it's now a 2. And this is going to equal x. So this is all size 4s, right, or quarters. So 5 plus 2 is 7. You will definitely, for some of your solutions, get fractions. Don't grab your calculator and change it into a decimal. This is a really nice value to have as the solution, 7 over 4. But let's go back and see if there was a different plan. Could I have tackled this differently? Because quite often there are choices. And depending on your choice, you can absolutely get the right answer. Maybe your choice made you get to that answer more quickly, or maybe your choice caused more trouble. Unfortunately, we don't know sometimes until we've gone through the work. Another approach here would have been to expand or multiply through that 4 first. So in this case, if I did that, the 5 stays alone. 4 to an x is 4x. Then 4 times a half. So a half of 4 would just be 2. So I'm going to get this -2. Well, that was the beginning of this section. What would I get rid of first, the 4 or the -2? I'll get rid of this -2 or this minusing 2 by +2 and +2. So 5 plus 2 on this side is 7. This is 0. I have 4x. Now I need to get rid of a times by 4. I will divide both sides by 4. So these become a 1. So there's my answer. 7 over 4 equals x. So it's the same answer as I had here. So was one way better than the other? I don't know. Depends how you are, with your numbers. They both work, but sometimes it pays to look ahead. And if you see after one step, you're going to be left with some fractions. If there was another choice, maybe try doing that other choice. Okay, now you can stop the video and you go to your booklet and you would be able to do page 40. And this is really the basis of equation solving. So the last section we're going to look at is how could this have just been made to look much more difficult? Well, what makes things more difficult? Lots of x's all over the place, lots of numbers all over the place, fractions, decimals, positive, negatives, brackets. The more things thrown at you, the more difficult typically the work is. Will our rules change? Nope. The rules are what they are. You're always going to start on the side where your x's are, and you're going to try and combine. If you have lots of x's all over the place, start slowly. Start on one side at a time and fix up each side. Okay, so we will start with 3x minus x plus 6, and then 7x minus 2 plus 3x. Whoa, all right, big deal. It's an equation. But I can't say there's a certain side to start on because there's x's on this side, but there's also x's on this side. These are called like terms, and these are like terms. So your first step will be to put them all together. There is a 1 here. So this is saying we're going to take 3 x's, subtract 1 x. That will leave for us 2 x's. Then there's a plus 6 and an equal sign. 7x plus 3x is 10x, and then there's a minus 2. So it's looking better for sure, but I have x's all over the place. You have to move them all to one side. So this is now where you make the best choice. In math, best choices involve, let's not have more negatives than we need. So if I need to move all the x's to one side, if I tried my first step and say, hey, I want to move them all to the left, to get rid of these positive 10x's from this side, I would have to go minus 10x and minus 10x. These will be gone. They'll be gone for sure. But 2x minus a 10x is going to leave me a negative number of x's. And x's are the most important part of this equation. So that was not a very good choice. And so deciding to move all the x's to the left, not a good choice. Instead, let's try and move all the x's to the right. So to get rid of these positive 2x's, I'll minus 2x there and minus 2x there. And in a second, you will see that was the best choice. These become 0. I now have 6 equals 10x's minus 2x's is 8x's. I still have my minus 2. Here you go with your friends again. Are you getting rid of the 8 or the minus 2 first? You're going to get rid of that minus 2. So you undid it by using opposites. This side is 8. Here you have an 8x. This is 0. Now you're going to get rid of a times by 8 by dividing by 8. This becomes just a 1x here, and this becomes 1. So you got through a very, very difficult equation, just step by step, working slowly, and you came up with the solution. You can check. It's very easy to go back and put a 1 here and a 1 here, and add a 6 to it. This side will be 8. Put a 1 here and a 1 here. You'll have 7 minus 2 plus 3. You'll get an 8 on that side. So the checks don't take very long, but they do for sure let you know if you got the right answer or not. Okay, we better do some fractions here. How about, and some brackets. Okay, let's say I have this. All right. It is an equation. Where are you going to start? Well, you're stuck. You have x's on this side, on the left side, and on the right side. So you're just going to start by doing some math first. Here I see I can combine these x's. Here I see I probably should expand first. So negative 2 times 4 is negative 8. Negative 2 times that 3x is negative 6x. There's a half. And negative 1x plus 2x would leave positive 1x, or just an x. Okay, now here comes this best choice of mine. I can move all the x's to the left, or I can move all the x's to the right. If I decide to move them all to the left, that will take going minus x and minus x. When you look at that scenario, I'm going to be left with negative x's. Nope, don't want to do that. So instead, I would make a choice of moving all the x's to the right-hand side in this case. So to get rid of minus 6x's or negative 6x's, I will add 6x's with the x's, add 6x's with the x's. This is 0. But these negative 8's are still left. This half is left. And now I have 7x. Okay, this is the friend situation. Would you get rid of the 7 first or the half? You will get rid of the half first by minusing a half from both sides. So having negative 8 and taking away another half from that is really negative 8.5. This is 0. This is 7x. Don't want to deal with mixed numbers. I would change this to an improper fraction. So 8 times 2 plus 1 is 17 over 2. So I have negative 17 over 2 is 7x. So how do you get rid of a times by 7? You divide by 7. Don't let anything here throw you off right now. You put a 7 underneath what you had here. So to show dividing by 7, you simply put a 7 underneath this side. If the 2 hadn't been there, you would have done that. There would have been no problem. The fact that 2 is sitting there doesn't change what you're doing. So divide by 7, divide by 7. This becomes a 1, and this becomes 17 over 14, and it's negative. So negative 17 over 14 is now your solution. Okay, that's a pretty crazy one. All right, so one more that it's worthwhile showing you, and again, because it's involving fractions. So this might be more of a challenge one, but after you see it once, then it's not so tough. So let's say you're given this. There's a lot of different ways you could tackle this, but let's just keep going with what our thinking is. We have a left side and a right side, but this looks weird. This with this M on the top. Well, we can do one quick step just to look at things a little differently. I'm going to remove this numerical coefficient more away from this M, and there's actually a 1 here. So really what's in front of this M is a negative 1/4. So in front of this M is a 5/6. So I'm going to write it differently. They're the same, but this might help me with a little bit of my math, depending on what my first approach is going to be. And then over here I have this negative 1/4 M. All right, so now I need to move all the M's to one side. Should I add a 1/4 M to each side, or should I minus 5/6 M's from each side? The good choice is adding a 1/4 M to each side. These will be gone, These need to be added together. So what I am looking at is 5/6 m plus 1/4 m is 4/3. Oh, I need a lowest common denominator though. So for 6 and 4, that'll be 12. So these need to be changed to 12s on the bottom. These need to be changed to 12s on the bottom. So that would go times 2. So the top, or the 5 times 2, is 10. The 4s would go by 3. So the top by 3 is 3. So now I need to add fractions. 10 plus 3 is 13. And that's all over 12ths. And these are m's. And then I have 4/3. Well, like we saw before, think about it. See if you have the answer. How would you get rid of 13 over 12? Think about what you need down here to get rid of that 13. You need a 13. Up here you need a 12. So that's the reciprocal of 13 over 12. But you'd have to do it here as well. Those all become 1. So we have our 1m timesing fractions. Nice. The numerators together, the denominators together. I can divide them both by 3. So my final answer will be 16 over 13. Okay. So there's your equation solving. The back of the book is all kind of a mishmash and good summary of all sorts of really good equation solving, which is going to help you to get in terms of your Math 20 and your Math 30. Okay? So this is really all you need for what we were going to do. But I'm going to talk about one more thing. We finished our year with linear functions and graphing. And something that we saw in graphing was this very handy form called slope y. Whoops. Whoop, there we go. Okay, we're back. Okay, this very handy form called slope y-intercept form, or y equals mx plus b. What did the significance of this? That m gave you your slope and that b gave you your y-intercept. So if somebody gave me an equation in this form and asked me to draw it, I don't need a graphing calculator. I don't need anything else. So let's say you were asked to draw, this is looking a little fuzzy here, I don't know if something happened. Let's say I wanted to draw y equals negative 2/3 x plus 2, and I had some graph paper. We've seen before, this is always your start. So you would have some graph paper and you would start at that y-intercept. So if that y-intercept is positive 2, I'm starting at positive 2 on the y-axis. Then I'm counting out the slope from there. This says go 2 down and 3 to the right. So 2 down and 1, 2, 3 to the right. That's all I need to draw this line. So I would take a ruler, I would join them together, put arrows on the end, and pretty darn fast I have drawn that line. But that was nice because this was given to me in y equals mx plus b form. What if it isn't? What if the y isn't all by itself? But if you know how to solve or isolate equations and variables in equations, within a step or two, you could take whatever they gave you and make it look like this, okay? So we'll do 2 examples. How about 2x plus y equals 5? And I want to draw that. I can't. I can't nicely draw this thing until it looks like this. So I need to get the y by itself. Well, this is an equation, right? I have a left side and a right side. If I want to get these y's by themselves, how would you get rid of a positive 2x? You would minus 2x from this side and minus 2x from this side. So these would be 0. I would have y. Now you're not going to go 5 minus 2. These are not like terms. These are separate. You can't add plain numbers to terms that have x's in them. So we know we want it to look like this. We want our x stuff first, followed by our plain numbers last. So the way to write this would be the negative 2 first, and then the plus 5 next. Now I can draw this. There's my start, and there's my slope. So I would have to have a grid. I need to go all the way up to 5. Okay, because that's my start on the y-axis. Positive 5 is right here. I'm going to go 2 down, 1 right. 2 down, 1 right. Do it again. 2 down, 1 right. Do it again. 2 down, 1 right. So eventually, if I did enough of these, I could join them and I would have my line. So that took no time at all. So one last example here, and we've covered lots. 4x minus 2y minus 6 equals 0. This is a special form in math. We didn't get to it this year. It's called general form. I know it's a line because it has x to the 1 and y to the 1, so I know this isn't going to be a linear function, so when I'm done, this thing will be a line. I don't know yet which way it's heading. I don't know the y-intercept, I don't know the slope, because it's all wrong. Not all wrong, but for graphing purposes, I would really like that y to be by itself. So let's tackle this and use everything that we've learned to make this look like y equals mx plus b. I need these y's by themselves, right? This is an equation. I have a left side and I have a right side. So I need everything gone from this. I'm going to get rid of these 6's by going plus 6 and plus 6. That was, let's say, my first step. So these are gone. I have 4x minus 2y equals 6. Now I'm going to get rid of these, right? Because these are further away from the y than the 2. So I'll minus 4x and minus 4x from this side. So these are 0. I have this negative 2y left, and these are not like terms, so I'll put the x's first and then the 6's, and they're positive. So now to get rid of a times by negative 2, I will divide by negative 2 to everything. That's called balancing. And then do some math to see what's left. Negative 2 divided by negative 2 is a 1, so there's my y. Negative 4 divided by negative 2 is 2, then my x. 6 divided by negative 2 is negative 3. So I've changed this now into y equals mx plus b. Think about it, where would you start? At negative 3, okay? So you would start on the y-intercept at negative 3. You would count this slope out. 2 up, 1 to the right. 2 up, 1 to the right. Maybe do it a few more times. 2 up, 1 to the right. 2 up, 1 to the right. You will have this nice relation, this function, and you could join the dots, okay? So that's how this is going to be useful in so many different units and different math classes and courses that you'll be studying. So understanding how to deal with equations and isolate and solve is very, very important. So you can now go back to your booklet on equation solving and go through all the different work there. And that should set you up for knowing how to solve any kind of equation. Thanks for listening. Bye-bye.